This video is to do with solving problems regarding projectiles. So a particle is projected with a speed of 7√5 meters per second at an angle alpha, where tan of alpha is equal to a half from a point on a horizontal plane, and then we have to find a couple of things. Recall that if this is a projectile heading off with a velocity of u, in the I direction, this is u cosine theta, and in the j direction, its velocity is u sine theta. So it's kind of got two parts, and we also have the tan alpha. We want to find what this angle is, what theta is. In this case, we're told that tan alpha is equal to a half. So, okay, I can do this. This is the angle alpha. I'm told that tan, which is opposite over adjacent, is equal to a half. So if I resolve that, I'm going to get that this here is equal to 1 squared plus 2 squared, which is √5. So from that, I'm going to have that sine alpha is equal to opposite over hypotenuse, which is 1 over √5. And I'm going to have cosine alpha is equal to adjacent over √5. So 2, or adjacent over hypotenuse, should I say, 2 over √5. So now I can write that the velocity of this vector is equal to u, which is 7√5. And it's cosine theta, and cosine is 2 over √5. And that's in the I direction. Plus 7√5 sine, and sine of alpha is equal to 1 over √5. 1 over √5. And that's in the j direction. So our vector v, our projectile, is travelling at, well, √5's cancel out, we're left with 14i plus 7j. So that's part 1 answered. That's part 1. We've now identified the initial velocity in terms of I and j. Now it's horizontal range, part 2. The range. Okay, so that's if our projectile does this, well then from here to here is the range. The range happens when sy is equal to 0. Sy is equal to 0 here, and it's equal to 0 when it lands on horizontal ground. So sy is equal to 0. So let's solve. And it's equal to s of x, by the way. S of x when s of y is equal to 0. So we're going to get s of x when s of y is equal to 0. At this point now, I'm going to write down that u of x is equal to 14. V of x never changes. That's always going to be 14 as well. These are meters per second. And s of x, well, is equal to 14t. I'm getting these from the two formulae. V is equal to u plus at. But there's no acceleration in the x direction. And s of x is equal to ut plus a half at squared. But again, there's no acceleration, so I'm just going to be left with the ut. So 14 by t. On the y side, u of y is equal to 7j, 7 meters per second. V of y, well, v is equal to u, which is 7, plus at. So acceleration is equal to minus 9.8 t. So its velocity will be this. So the time is relevant here. And s of y is equal to, well, it's equal to ut plus half at squared. So it's 7 by t minus half at squared, so 9.8 divided by 2t squared. S of y is equal to 7t minus 4.9t squared. Now, the range occurs when the s of y, when the displacement of y is equal to 0. So here's our displacement of y. So we're going to get s of y has to be equal to 0. So we're going to get 7t minus 4.9t squared is equal to 0. Factor out a t, 7 minus 4.9t, and that's equal to 0. Well, that means that s of y is equal to 0 at t is equal to 0. So when time is equal to 0, the displacement is 0, that makes sense. And it's also equal to 0 when 7 minus 4.9t is equal to 0 as well. And that implies that we're going to have 7 is equal to 4.9t, bringing this across to the other side. And that implies that t is equal to 7 divided by 4.9 seconds. Leave it as a fraction. Now, That's the time when s of y is equal to 0. Now we're going to get s of x at this time. Well, s of x is equal to 14t. That's our range. So s of x, our range, is s of x, at t is equal to 7 over 4.9. And s of x is equal to, I was going to go back up and check again, 14t. So it's equal to 14 times 7 over 4.9. And that's going to give me, and that equals 20 meters. I think our units are meters. So 20 meters is the range. Okay, let's have a look at another question now. Okay, the first thing I'm going to do is I'm going to do a quick angle theta, and I'm going tan of theta is equal to 3 over 4, so opposite over adjacent. That means this is 5. That means that sine theta is equal to 3 over 5, and cosine theta is equal to 4 over 5. I know that my particle is projected with a speed of 35 meters per second at this angle here to the horizontal. Write its initial velocity in terms of a, I, and bj. Okay, so in other words, v is equal to, that's equal to 35, and cosine is equal to 4 over 5, so 4 over 5 I, plus 35 by 3 over 5, which is sine theta j. So our vector, its initial velocity in the I and j direction, is equal to 28 I plus 21 j. Okay, now we have to find its magnitude when it's 10 meters off the ground. So that's going to happen at 2 points, here and here. As it happens, these magnitudes will be the same, because if something goes up with a magnitude, it comes down with the same magnitude, not taking air resistance into account. But if there's no air resistance, if you send something up at this height going up, it'll have the same magnitude as that height coming down. Let's move on. So the first thing I'm going to do is I'm going to do my u of x, my v of x, and my s of x. And I'm going to get my u of y, my v of y, and s of y. So u of x is equal to 28, and v of x is equal to 28, and s of x is equal to 28t. Okay, so if you want to just, v is equal to u plus at, and you can see in the x direction there's no acceleration, and s is equal to ut plus a half at squared, and again there's no acceleration in the x direction, so it's just that. U of y is equal to 21. Now v of y is equal to u plus at, so it's 21 minus 9.8t. S of y is equal to ut, which is 21t, minus half of 9.8, which is 4.9, because it's half of a, which is 4.9, and t squared. So there's our 6 equations that we're going to be using to most problems we're going to be solving in this projectiles type of area. Now, we're looking for the magnitude when it's 10 meters off the ground. When it's 10 meters off the ground, that means Sy is equal to 10 meters. So Sy is equal to 10 meters. So we're going to have 10 is equal to 21t minus 4.9t squared. So that's just a quadratic equation. I'm going to bring my 4.9t squared over here. Minus 21t plus 10 is equal to 0. You can try factoring it out, multiply everything by 10 and get rid of the decimals and stuff and try to factorize it, or else just stick it into a calculator, your quadratic formula, and you're going to get t is equal to. Now I got these 2 times here in my quadratic, so this will be 5.46 seconds up here, or 0.4, so it's about a half a second, and then we're going to get 3.74 here. This is an approximation, I rounded it. So that's this time. So now what's its magnitude? So in order to get its magnitude, we need to get Vx at this time and Vy at this time. So Vx is equal to 28, it doesn't change, and Vy, it's going to give me 21 minus 9.8 by, we'll go 0.546, and that's going to give me, so I got 15.649. So our vector at this point, a v, or a velocity of our vector, I keep saying vector, but the velocity of our projectile at t is equal to 0.546 seconds, and it'll be the same, and at 3.7, we can check that actually as well to make just to show that it's the same magnitude. It's going to be 28I plus 15.649J. That's our velocity is equal to that. Our projectile is equal to that's its velocity in the I and J direction. To get the magnitude of it, okay, because that looks like this, doesn't it? You're going to have 28 here, 28, and we're going to have 15.649 here. So we're trying to get the magnitude. So it's the square root of 28 squared plus 15.649 squared. And let's see what that's equal to. That means our magnitude is equal to 32.07 meters per second. That's the velocity at that particular point. Now, so we want to find its velocity when it's 10 meters off the ground, corrected 2 decimal places. So I'm getting 32.07 meters per second. Just for fun, let's put in the other time here and just see. We should get exactly the same, the velocity on the way down. So this is the velocity on the way up, okay, but we should get the same velocity coming down. So using here at this point. So let's just check. Let's work that out. So I've got my v of x is still 28. That hasn't changed. V of y on the way down is going to be 21 minus 9.8 by 3.740 at this stage. So that's going to give me Vy equal to. So that's equal to Vy is equal to minus 15.652. And as you can see, on the way up, it's doing 15.649. On the way down, it's doing 15.652, which is the same. It's just a rounding error with these numbers here. So as you can see, the velocity, the magnitude of the projectile coming down is the same as it is going up. Okay, I think that's enough for this video. I hope that helped. Cheers.